Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns the product rule. This guide describes how the product rule is used to differentiate functions which are two or more basic functions multiplied together. It also shows you how to use your page in an efficient way when performing lengthy calculations. Introduction. The most important skill when differentiating is being able to identify the form of the function you have to differentiate. Once you know the form of the function, you can choose an appropriate rule to differentiate it. Many complicated functions are created by combining basic functions in some way, usually by addition or subtraction, multiplication, division or composition. See study guide, more complicated functions and the fact sheet, 5 basic functions. This guide is concerned with differentiating complicated functions which are made by multiplying together more basic functions. In numeracy, the result of multiplying numbers is called their product. Extending this idea, the rule to differentiate a function which is the result of multiplying simpler functions is called the product rule. The product rule is given by if y equals u multiplied by v, then dy by dx equals u multiplied by dv by dx plus v multiplied by du by dx. Here the function you are trying to differentiate, y, is made by multiplying together the functions u and v. Importantly, u and v are basic functions of x, and so they take the form of one of the functions in the table given on the next page of this guide. The derivative, dy by dx, is dependent on u and v, and their respective derivatives, du by dx and dv by dx. To use the product rule, you need to be able to differentiate basic functions. Methods to do this are discussed in the study guides, differentiating y equals ax to the n and differentiating basic functions. You should read these guides and familiarise yourself with the methods discussed in them before you continue with this guide. The results are summarised in the following table. Rule 1. Function k. Derivative 0. Rule 2. Function a multiplied by x. Derivative a. Rule 3. Function a multiplied by x to the power n. Derivative a multiplied by n multiplied by x to the power n minus 1. Rule 4. Function a multiplied by the sine of kx. Derivative a multiplied by k multiplied by the cosine of kx. Rule 5. Function a multiplied by the cosine of kx. Derivative minus a multiplied by k multiplied by the sine of kx. Rule 6. A multiplied by e to the power kx. Derivative a multiplied by k multiplied by e to the power kx. Rule 7. Function a multiplied by the natural logarithm of kx. Derivative a divided by x. Throughout this guide, these results will be referred to by the rule number in this table. The product rule is a two-stage rule, in a similar manner to the power rule. First, you must ensure that the function you are dealing with fits the pattern, that it is a product of two basic functions. If this is the case, you can proceed to the second part, which gives the derivative. Example. Which of the following functions can be differentiated using the product rule? Y equals 16x squared multiplied by sin x. This function can be made by multiplying the basic functions 16x squared and sin x. 16x squared can be differentiated using rule 3 and sin x using rule 4. If you set u equals 16x squared and v equals sin x, then y equals u multiplied by v, and you can use the product rule to find the derivative. Y equals sine of 16x squared. This function is made by composition, as it is the sine of 16x squared. As it is not the product of two elementary functions, you cannot use the product rule here. In fact, you can use the chain rule to differentiate this function. See the study guide, the chain rule. Y equals 16 sin x. Although this function can be differentiated by the product rule, with u equals 16, which can be differentiated by rule 1, multiplied by v equals sin x, which can be differentiated by rule 4, it can be directly differentiated by rule 4 in the table, with a equals 16 and k equals 1, with no need for the product rule. Both methods give the same answer, but the latter is easier. Y equals 16 sin x divided by x squared. Upon first inspection, this function looks like 16 sin x divided by x squared, which would lead to use of the quotient rule. See study guide, the quotient rule. However, you can think of the function as 16 sin x multiplied by x to the power minus 2, using the laws of indices. 16 sin x can be differentiated using rule 4, and x to the power minus 2 using rule 3. If you set u equals 16 sin x and v equals x to the minus 2, then y equals u multiplied by v, and you can use the product rule to find the derivative. Using the product rule. Once you have decided that your function is the product of two basic functions, and therefore it is appropriate to use the product rule to differentiate the function, the next step is to assign u and v. In the product rule, it does not matter which function you assign as u and which you assign as v, unlike the quotient rule. See study guide, the quotient rule. When this is done, you can proceed to the second part of the rule. Looking carefully, dy by dx equals u multiplied by dv by dx plus v multiplied by du by dx. The derivative is made of 4 separate parts, and you can think of the product rule as u multiplied by the derivative of v plus v multiplied by the derivative of u. As you have already defined u and v, all you need to do is to find the derivative of each of them. Next, you substitute u and v and their derivatives into the product rule formula and simplify if necessary. You may find it useful to divide your page vertically into an answer space, where your answer will be written, and an exploring space, where you can do any working and thinking which informs your answer. Usually, in product rule calculations, the exploring space is simply a list of the mathematics that you need to calculate in order to perform the substitution, and any algebra you need to think about, such as factorisation. However, if you progress to more complicated mathematics, the exploring space offers a vital place to play with ideas as you work towards a solution. Example: differentiate y equals 16x squared multiplied by sin x. As mentioned in example B above, the function can be differentiated by the product rule, where u equals 16x squared and v equals sin x. Divide your page into answer space and exploring space. The question is to differentiate y equals 16x squared multiplied by sin x. If you set u equals 16x squared and v equals sin x, y equals u, which is 16x squared, multiplied by v, which is sin x. As you have a product, you use the product rule. So, dy by dx equals u multiplied by dv by dx plus v multiplied by du by dx. Differentiating u with respect to x using rule 3 gives du by dx equals 32x. Differentiating v with respect to x using rule 4, dv by dx equals cos x. Putting these results into the product rule, u equals 16x squared multiplied by dv by dx, which equals cos x, plus v, which equals sin x, multiplied by du by dx, which equals 32x. Removing the brackets and using Snalphabet, this equals 16x squared cos x plus 32x sin x, which has a common factor of 16x, and so it equals 16x multiplied by x cos x plus 2 sin x. So the derivative of y equals 16x squared sin x is dy by dx equals 16x multiplied by x cos x plus 2 sin x. By writing u, v and so on in the exploring space to the right of the line, you keep them apart from the flow of the answer to the left. It is also useful for further reference and checking when substituting, especially so when examples become more complicated. Example: what is the gradient of y equals 5e to the x multiplied by cos x when x equals pi? The function can be thought of as 5e to the x multiplied by cos x. So, by setting u equals 5e to the x and v equals cos x, you can use the product rule. Divide your page into answer space and exploring space. The question is, differentiate y equals 5e to the x multiplied by cos x. By setting u equals 5e to the x and v equals cos x, y equals u multiplied by v. So, you can use the product rule to differentiate. Dy by dx equals u multiplied by dv by dx plus v multiplied by du by dx. Differentiating u with respect to x using rule 6 gives 5e to the x. Differentiating v with respect to x using rule 5 gives minus sin x. Substituting into the product rule, dy by dx equals 5e to the x, which is u, multiplied by minus sin x, which is dv by dx, plus cos x, which is v, multiplied by 5e to the x, which is du by dx. Using Snalphabet, this equals minus 5e to the x sin x plus 5e to the x cos x, which factorises to give 5e to the x multiplied by cos x minus sin x. So, the derivative of y equals 5e to the x cos x is dy by dx equals 5e to the x multiplied by cos x minus sin x. Remember that the derivative and the gradient are equivalent, so when x equals pi, the gradient is the value of derivative when x is equal to pi. This is 5e to the pi multiplied by cos pi minus sin pi, which equals minus 5e to the pi, as the cos of pi is 0 and the sine of pi is 1, which equals minus 115.703 to 3 decimal places. Further guidance and information. If you have any further questions about calculus, or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of calculus, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.